Are you able to see my screen?
Yes, ma'am.
Okay. So I'll start with this session. This session is getting recorded. Please mute your volume. I could hear the echo. Thank you. So in last session, what we have seen is an introduction to HDFS concepts. We have seen what is the definition of HDFS, and then we have seen the three important keywords of HDFS. It is a very large file with streaming data access pattern running on clusters of commodity hardware. So this is the definition of HDFS. So HDFS are usually used to record a very large files, and it works in a pattern where you can have a single write and multiple read, and all the systems which we used in this cluster is and commodity hardware. So the cheapest hardware, what we can use it in a personal computer, the similar kind of an hardware we will be using here in Hadoop clusters. The second point was when you should not use Hadoop. So when you will not use Hadoop is when you require an application, when your application require a low latency data access. That means when your application wanted to retrieve a data in a very less time, then you will not go for an HDFS storage, because more time. It don't give you a data in a milliseconds or in the multiples of milliseconds. So that kind of an application will not fit for HDFS. And when you will have lot of small files, then also you will not go for HDFS. The third one is that whenever your application require multiple updates, then you will not go for HDFS. Then we have just seen the concept of what is called as a block, what is a name node. So today we will be seeing about what is a data node, and we will be starting about the various ways in which your name node can be replaced. So in HDFS, each block is capable of storing 64 MB of data by default. Datas are not just saved in one place. By default, it is saved in with +2 replicas. That means in 3 places your datas will be saved. So if one data node get failed, the name node will understand and then replace the data node with the data which is available in the replicas. So that is how a name node will replace a data node. Let me check if I have a setting of cutting the beep sound. I'll explore, and by next class I'll do that. So whenever someone joins, we are able to hear a beep sound. So coming back to the blocks, an HDFS block contains 64 MB of data, and each block is each data block has +2 replicas. So then what is a name node? So both HDFS and MapReduce works in master slave fashion. In HDFS, the name node is called as a master node and the data nodes are called as slaves. So what is the responsibility of the slaves is that whatever task is given to that, it will complete the task and report back to the master, which is the name node. So now a name node has two types of, an HDFS cluster has two types of nodes, which is work in a master worker pattern, the name node and the data node. Now coming to the data node. So data nodes are considered to be the workhorses of the file system. So what they do, they store and retrieve blocks when they are told to do so. So when a client or when a name node is asking it to store a data or retrieve the data node will be able to do that. And they also report back to the name node periodically, telling that these are the list of blocks that are there in my storage. So without the name node, so if a name, we also called a name node to be a SPOC, a single point of failure. Without the name node, the file system cannot be accessed. If a name node get failed, that means we will not be able to access the data in the file system. Though we have 3 copies of data, but still we will not be able to access the data from the data nodes, because name node is a primary node which is contains the metadata information about the data node. So which file systems data, which files data is saved in which data node, where are the different locations it is saved, all these information are available only with the name node. So that is why we will not be able to access the files data when a name node get failed. So there are different mechanisms to handle the name node. So the mechanism to handle name node failure. So how do we handle data node failure is that the data node is supposed to send an RB signal to the name node. If the data node is not sending the signal to the name node, it is understood by the name node that the data node has some issue. It may have an hardware failure or some interrupt. So what it will do, it will go and find out the reason for it, and if it is not going to pick up, what it does is it cuts the data node and replace it with another data node by dumping the data which is available in replica nodes. So that is how a name node replaces a data node. Now, how to replace a name node when it gets failed? So there are two simple ways to replace when a name node fails. The first one is to back up the files that make up the persistent state of the file system metadata. So a name node will have a set of data in it. So there should be a backup. So to have this backup, we should first have Hadoop to be configured in such a way that you are able to back up the data of the name node. So this is usually done using a remote NFS mount. So NFS stands for network file system. So in order to overcome the name node failure, there are two simple mechanisms. One such mechanism is that there should be a backup of your name node using NFS mount. That is, using a remote NFS mount, there will be an backup of your name node. Second way is that you should have a secondary name node. So you have a primary name node. If that primary name node fails, then secondary name node should take over the work of the primary name node. So what happens here is that the name node, when the data are getting saved in the name node, primary name node, in some time interval, so with a gap of some time interval, the data will be backed up in the secondary name node. So when the primary name node fails, the secondary name node will take over the primary name node position. So these are the two ways in which you can handle the name node failure, but still this process will take minimum 30 minutes time to do this. That is why we go for a concept of high availability. So when a data node fails, you will be able to replace it. When a name node fails, you will be able to replace it. So when a data node fails, the name node will replace the data node. When a name node fails, there are two simple mechanisms. One is that having the name node's backup. The usual configuration is to write the local disk as well as a remote NFS mount. So these are the two ways, these are the two things which has to be done. So your data, your name node data have to be written to a local disk as well as a remote NFS mount. So which is a network file system. Other way, having a secondary name node. So when any data node updates the information to the name node, it gets updated in the primary name node. With some time interval, it also gets updated in the secondary name node. At the time of the primary name node getting failed, the secondary name node will take over the role of the primary name node by doing some steps. So this will take 30 minutes time, but still you will be able to retrieve your data after 30 minutes. But 30 minutes is more time. In order to overcome this disadvantage of waiting for 30 minutes, we have a concept called as HDFS high availability. So before that, let me cover what is HDFS federation. Then we will go for HDFS high availability. Now, we said that an Hadoop cluster will be capable of storing more gigabytes of data, petabyte, yettabyte, zettabyte amount of data it will be able to save. We will not set up the Hadoop cluster in that first go itself. It can store a yettabyte or zettabyte amount of data. What we will do is that a decent amount of space will be allotted for an Hadoop cluster. When the request for more file storage is coming in, then we will be increasing the data nodes. Now, there is an option of increasing the data node. When the number of data nodes are getting increased, the metadata information about the data node also should be increased. So for that, we call it as a scaling up of name node. So this concept is called as HDFS federation. So how do we do here is, one name node can manage all the files rooted under a particular folder. Say user, share, these are an example of the folders. All the data which are saved under this particular folder will belong to one namespace of name node. So that is how we can scale up the name node also. So I repeat again, we can in any Hadoop cluster we can store huge volume of data. This data can be yettabyte, zettabyte, petabyte, a large volume of data. At the time of setting up the Hadoop cluster, we will not set up as per the petabyte amount of data. The data nodes will be added as and when there is a request for file system storage. When you have a request to store the data, then you will add up the data nodes. Now this is the process you can add the data node. But when you have a data node keep on adding, the metadata information about the data node also should be saved in the name node. So the capacity of the name node cannot be increased drastically. So what we do is that we give a dedicated namespace name node for a particular root or a particular folder. Under this folder, whatever data are saved, that folder will have, say, name node 1 as a primary name node, name node 2 as a primary name node for something which is under the folder share, something under the folder called as user. So like this, when we do, we call this as an HDFS federation. Now coming to the concept of high availability. So I told you, when a name node fails, you can replace your name node. But you can do it in two ways. It takes time. It takes minimum 30 minutes of time to for a secondary name node to act as a primary name node. So during this 30 minutes, you will not be able to access any of your data from your Hadoop cluster. So this is a disadvantage. To overcome this disadvantage, we have a concept called as high availability. So the combination of replicating name node metadata on multiple file systems and using the secondary name node or to create checkpoints protect against data loss but does not provide high availability of the system. So we have now multiple name nodes. So if one name node fail, it will fail only slash root. Under that folder, whatever data is there, we will not be able to access. So it's, to an extent it is okay, but still if we wanted to access the data which is under a root or under a user, a particular user or particular folder, then there should be a possibility that if one name node fail, that replacement should happen quickly. So that with the concept of HDFS federation and with the concept of secondary name nodes, still we have a gap for accessing the data. So the name node is still a single point of failure. So what happens when a secondary name node have to take over the role of a primary name node? There are some steps which it has to do. First, there will be a time gap. That is, I kept on telling you that a primary name node, whenever a data node is updating to the primary name node, after some time interval only, that data will be updated in the secondary name node. So, up-to-date data will not be there available in the secondary name node. Some data would have got missed. Now, that some data you have to access from NFS. So, that will take time. After that, you have to load the namespace image into memory. So what is mean by load its namespace into memory is, now as a client, I will contact a name node. I will ask the name node client interface. I'll ask the name node that I wanted to store the data or retrieve your data from your Hadoop cluster. So that namespace address will be with the client interface. Now when the primary name node is not working, when secondary name node have to take over, then the secondary name node's address have to be given to that client's interface. So that is one of the steps which it has to do. So load the address of the secondary name node into memory. Second one, replayed its edit log. So I have a copy of it. Now, if I am a secondary name node, I have to glance through it. What I have to glance through it is how many data nodes do I have? How much space each data node will have? Which file systems data are saved in me? All these information as a secondary name node I should understand. That is what it is called as replayed its edit log and receive enough block reports. So what do I mean by enough block reports is that how much space of memory is left in each block, each data block. That one also the new name node should understand. So after doing all these steps only, a primary name node will be replaced by a secondary name node, which will approximately take 30 minutes of time. So to overcome this disadvantage, we have a concept called as high availability, which is applicable from 0.23 release of Hadoop. So what happens here is, we have a pair of name nodes. So there is no concept of a primary name node here. We always have an active standby configuration. So primary name node, secondary name node means you had a primary name node and that primary name node will periodically update the to secondary name node with some time interval. But here we have two name nodes. One is an active name node and another one is a standby name node. So when a data node updates the information to the name node, it will simultaneously update to both the name nodes. It will update to active name node as well as standby name node. So when a standby name node comes up to read up the end of the shared edit logs and then it synchronizes. So what happens when your active name node fails? Automatically the standby name node can act as a active name node and there won't be much time lag for you to retrieve the data or store the data inside your data nodes. That is the advantage of Hadoop high availability. I mean HDFS high availability. I'll repeat again. So when a name node fails, already we have seen there are two concepts. One is the backup of the information of the name node will be available in the local disk as well as in NFS. So network file system. Now another way, you will have a secondary name node. Whenever a data node updates the information to the primary name node, what happens is the primary name node will periodically with some time interval will update it to the secondary name node. So these things will take time. Minimum it takes 30 minutes time at the time of a primary name node failure for a secondary name node to take over. In order to overcome this disadvantage, we have a concept called as HA, high availability. In this concept, what we have is that we have an active name node and we have a standby name node. The data node, while updating the information, it will update simultaneously to both the name nodes. So that is the concept. That is the concept of high availability. Is it clear? Are you getting my point about high availability?
Yes, ma'am.
Okay.
Yes, ma'am.
We have few more points here. We have some concept called as failover and fencing. So what do we mean by a failover is that when an active name node is failed and when your standby node has to take over the work of the active name node, you have some failover controllers these controllers are called as a pluggables. So we have seen in ecosystem a concept called as zookeeper. So the zookeeper will ensure only one name node is active. If the active name node is not active, then the zookeeper will make sure the standby name node will do the work of an active name node. But any given time, only one name node will be active. So that is how we maintain. That is how in Hadoop they maintain the failover. So when an active name node fails, the standby name node will take over the job of an active name node. Though we have two name nodes simultaneously, the data nodes are updating, but still the zookeeper will ensure at any given time there is only one active node. When this active node is not working, only then the standby active node will go into picture. So this is not the only way. Even the administrator of Hadoop will be able to do it automatically. Manually. So when they will do it manually is when they want to do some maintenance work. So that is called as a graceful failover. So when some administrator wanted to have some maintenance to the system where your active name node is failed, then they will do this process manually. So this one is called as a graceful failover. We also have something called as an ungraceful failover. So what I meant now as administrator is graceful failover. So this graceful failover will happen when for some maintenance work, some unpredictably something has happened to the system, then that is called as an ungraceful failure. Someone intentionally wanted to attack the system, then we call that to be an ungraceful failover. So that time there is a concept called as a fencing. So someone intentionally wanted to disturb the system. We have a concept called as fencing. What does that fencing means is when the Hadoop ecosystem understands that a name node is no longer active, the active name node is no longer active and it got disturbed, what it will do is it has a concept called as stone it. That is shoot the other node in the head. So when see here you have a concept called as shoot the other node in the head. So what they do is the previous active name node will be fenced graphically known as stoned. That is, it can no longer be the part of this particular ecosystem. It will be removed from the Hadoop cluster. So that is called as stoned. Another way is that the name node will be killed. So we will not be able to access that at all. That will be completely killed. So there is a small difference between killing the name node and shoot the name node in the head. So the location where the name node is there. So shooting that one is called as a stone. Name node killing is that you are not going to anyhow you are not going to use it at all. Not only the location is going to be removed, you are not going to use that name node at all. So this is how it will ensure that the failure of name node is active. So what we have done now is that we have understood the concept of what is a data node, what is a name node, how a name node failure have to be handled, how a data node failure have to be handled. These are the basic concepts of HDFS. So I'll stop sharing my